Archimedes was an ancient mathematician, and he's generally regarded as one of the greatest mathematicians of all time. And there are a few different stories about some of his really brilliant ideas. And the one that we're talking about today is about Archimedes' principle, which deals with density and volume, and later on our discussion of buoyancy that fits right into our eighth grade curriculum. So here's Archimedes, and the story of Archimedes begins with a king, and the king wants to have a new crown made of pure gold. So he takes some of his gold, he takes a brick of gold and gives it to his goldsmith, and he tells him to make a brand new crown for him. So the goldsmith makes the crown, comes back, but the king is a little bit suspicious because he thinks the goldsmith is a little bit shady, and so he's wondering if the goldsmith ripped him off a little bit and took some of the gold for himself. So being a pretty bright king, he weighs both of them, and he sees if the weights are the same to see if maybe some of that gold is missing. So he puts it on a scale, and sure enough, the gold bar, the amount of gold that he gave him, is equal to the crown that was made. But he's still suspicious. And he can't figure out how the goldsmith might have ripped him off. So he calls his man Archimedes. And Archimedes comes in, and he understands that what the goldsmith might have done, possibly, he could melt down that gold. And let's say he melts down the gold, and the gold occupies this much space. But if he melts it down and then he takes some of that gold away, let's assume that that's the same. He takes some of that gold away, and he keeps some of the gold for himself. He's going to probably replace it with a different metal. All right, so he'll replace it with maybe silver. However, silver is much lighter than gold. So in order to make up for the weight difference, he would have to add some additional silver to make up for the weight. And that way, when the king put it on the scale, answer the phone. That way, when the king put it on the scale, the masses, or I'm sorry, the weights would be equal. All right. However, because he would need to add much more silver, the volume would be different. All right. So what he does is he thinks about it and thinks upon it, and he can't figure it out. But he's only given 3 days, and the pressure's getting to him. So he decides that he needs to rest, and he takes a bath. So the story goes, and he draws himself a bath, and then when he gets into the tub, he realizes, right, let me draw him. All right, this is going to be a little tricky. Well, let's put him here, and we'll go like this. His legs come up there. I don't know, something like that. That's okay, I guess. All right, so he's in the tub, and he realizes that when he gets in the tub, the water rises. And it dawns on him that that's the way he's going to figure out if the gold is pure in the crown or if the goldsmith ripped off the king. Because he realizes that if he takes the brick of gold and he places it into a canister of water, he can watch the sea. Make this blue. He can watch the sea how much the water rises. All right, and then if he takes the same type of canister and he fills it up with the same amount of water, like that, and in that water he puts in the crown, he knows that when he does that, here's our crown, when he does that, if it's the same volume, then the amount of water will rise up to be the same. But if the volume of the crown is greater, just like they kind of suspect from talking about it here, because if he added more silver, the volume would be greater, right? The volume would be increased. So if he added more silver, the volume would be greater, and when he put in that crown, the water would rise even higher. All right, and there's a word for that we need to write down, and that word is called displacement. Displacement. And all displacement means is the fact that the water will move, that whatever object you put into the water will take up an amount of space, will take up amount of volume, and the water will rise and move away from it at the same amount of space, right? If I put in a brick of gold that's like, I don't know, 100 milliliters, or 100 milliliters of space, the water will rise, 100 milliliters. Right, and that term is again displacement. So in the lab, what we do in the lab, it's easy enough to figure out the volume of regular objects, where we can just take a formula like length times width times height, or we can even look up a formula for a pyramid and even a sphere. There's even a formula for a cone, where just mathematically you can figure out the volume of something. But for something like a crown, or even when we're studying rock cycle, and we might find the density of a rock, there's no formula for something that odd shape. So what we can do is the same thing Archimedes did. We can put it in, let's say, a beaker. All right, and let's say we start off when we put in 100 milliliters of water, and we put in this strangely shaped rock, put it in here, right? And we watch to see how high the water rises. So let's say it rises up to this level, and it goes up to 150 milliliters, right? And so it went from 100 to 150 milliliters, and the difference would be 50 milliliters. So it was displaced. Remember that word? It was displaced by an amount of 50 milliliters. So that means that this rock took up 50 milliliters of space because it made the water move an amount of 50 milliliters. And by the time you watch this video, I hope in the lab we've already spoken about how 50 milliliters will also be equal to 50 cubic centimeters. And if you don't remember, I believe I have that on another video. You can search it out. So Archimedes, pretty smart dude, and he figured out that the goldsmith was ripping off the king, and we're not sure what happened to the goldsmith, but probably not good. Hopefully I'll see you on the next video. I know this one was kind of long, and we'll talk about Archimedes and the whole idea of buoyancy. All right, see you on the next one.